So the first thing to look at was the camera. These days you can get a pretty good camera, very similar, except at very low lights, to the sensitivity of these EMCCDs. You can, for roughly 10,000, I think, maybe 12,000, you can get a CMOS camera. But you know, if you don't want that incredible low noise performance, you can come pretty close by spending a hell of a lot less money these days with the, and I think it's sort of mobile phone technology that really pushed CMOS cameras to be to advance as far as they've come, really. So this is the camera we went for. It's by a company called FLIR. I can't remember what the F and L stand for, but it's infrared, the other part of the name. Quite a well-known company in terms of low-end, low-cost microscopy. People know this name. It used to be called Point Grey. And they make these sensors which are absolutely amazing in specification. So you can get a system with a ridiculous number of, can you see the mouse pointer? I've gone to the right. So you can get 2.5K by 2K chip, respectable frame rates, which you can quadruple quite easily by binning 2x2. And nice, you know, it's not 8, it's a 12-bit system, so quite a good dynamic range. What you don't get is the low noise performance. So when you're going very low light and you crank up the gain, you have a noisier background than if you'd spent a lot more money. And that's essentially it. And also another difference is that you wind up getting systems with much smaller pixels. Research grade cameras usually have 10 microns or so. And the reason for that is that the optical systems are set up for 100 times, let's say on 100 times lens, that would give you nice 100 nanometer at the level of the sample size pixels, and that's kind of a sweet spot for sampling. There's not much point in going smaller than that for sampling because you're oversampling then at that point. But it turns out that for our design, what we originally saw as a disadvantage, these tiny pixels, if you combine it with a shorter tube lens, it actually works in your favor because it just shortens the path length to the camera. You wind up with the exact same NA of imaging. The effective magnification of the system goes down because you're using a shorter tube lens. But the overall result is actually a more compact system with the same sampling resolution that you would have in with a more expensive camera system. Okay, and these are much cheaper. So there's sort of three. It depends on the chip size you choose, but we're sort of, I think the ones we went for are roughly £700, something like that. And then finally, a bit of trivia. If you've been following the Mars mission of the Perseverance lander, it turns out they use the same camera on their lander. They've got 6 of them to monitor the 7 minutes of terror, which is their entry, descent, and landing on Mars, and it's being recorded on Chameleon 3 cameras, which at least says something about they're expecting them to be robust and last a while, which is a good sign. So yeah, the one. In fact, I think it's going to be earlier this week. You're going to start seeing footage because it takes forever to download these enormous movies from the landing sequence. But I think it should, if it doesn't hit the news, you should maybe chase it up because they're going to see some amazing pictures of parachutes opening and dust flying. And so essentially, these are the cheap cameras on that rover, which they allow to be exposed to the dust of Mars before they take the lens caps off their real imaging cameras when they come to do their proper sensing. Okay,